Alan coming up.
Let's see. All right.
Yeah, we don't see you yet, or we don't see your screen.
Okay.
Awesome.
How's that? Let me share screen.
And this is Alan Benjamin, the president and CEO of Gig.io, and you can take it.
All right. Let me see if I have put it into slideshow mode.
We are not there yet.
Okay, hold on for just
See,
one
like your
second.
normal PowerPoint view right now.
All right. See if I bring this up. Why is that showing up over there? Do you see my screen?
I see your normal PowerPoint view, like the one you use to edit the document.
Yeah, okay. That's why is that showing up over there?
Maybe clicking slideshow.
Yeah, I'll just do, well, I tried putting it into slideshow mode.
Oh, so you can click slideshow on the top and you might be able to swap screens.
Okay, let me try that.
But from your main screen though.
Yep.
Okay, now is the correct view.
Okay. All right, fantastic. Let's go with this one. So I'm Alan Benjamin. I'm the CEO at Gig.io, and Sumit really did a nice job of setting me up here in terms of the presentation when he talks about composability, and I think Gig.io is what we're going to talk about here is we pick up and give you even more tools on top of that one. So if we look at the transitions here that are going on in the data center, what is causing them and what is the result to users? Lots of people talk about the explosion in data, and the effect on network traffic is even larger. So if data is exploding, network traffic is doing even more than that. And I'm going to show you some statistics here and some numbers, which I think are sort of an amusing way of looking at it. But the network traffic itself is huge, and it's becoming an issue. Combining now with the emergence of heterogeneous processing, different accelerators of various types, GPUs, FPGAs, and so on, in order to be able to solve some of these problems. And third, because of the amount of data that's being generated and the necessity of bringing it in or pumping it out, increasingly people want to move a set of this data outside of a data center and move it to a remote location. And so what we're seeing now is a driving desire on the part of customers now for what we call agility, flexibility, and manageability, because these transitions, the rate of change across the hardware and software stack is enormous. It is driving large degrees of anxiety within the folks that have to put in and manage infrastructure, of just how much usefulness are they going to get out of the infrastructure. And in large measure, it's been one of the big reasons that the public cloud has done so well, or people have simply given up on their ability to keep up with the change and outsource that change. Number two, with the growth in data as a corresponding rise in the growth of artificial intelligence, AI, to do a great job, needs the data. And on the other hand, now that you have all that data, in order to be able to process it, you have to use AI techniques. And there's a notable difference in the workflow. And so we'll talk about that a bit. And if you're going to put things particularly outside the data center, the importance of more sophisticated cluster management tools, workflow management tools become ever more important, remote management and remote control. So today, Ethernet or InfiniBand, the vast majority, of course, being Ethernet, is used across all of the traffic classes. So whether it's the file and the object store itself, that huge tsunami of data, whether it's the computational traffic, whether it's MPI, libfabric, interserver memory messaging, could be other sorts of things, this computational traffic. And then common now is the, we'll call it extended composition, the RDMA traffic, NVMe OF, GPU direct RDMA and other RDMA constructs. And it's all running across the Ethernet network, which is becoming increasingly more and more congested, which affects the performance of everything running on the network. And then Sumit did a great job, really, of talking about a new traffic class of server composition, where you can take your storage, you can take your accelerators, you can move them outside of a server, you can put them into resource boxes in a rack or across racks. And he talked about a PCI network in order to be able to do this as a separate device. And it really, the disaggregation, as it really does add a tremendous amount of flexibility and adaptability into the network. And we talk about congestion, and I went to look for various statistics about network congestion and so on, and I thought this was an amusing way of looking at this. And the timeline at the bottom here is in 5-year blocks, and it shows the issue here associated with congestion in terms of the number of IEEE papers, which is obviously the gold standard in this area, that are published on network congestion. So I went to the IEEE database, I took out everything associated with wireless networks, and in 2000, there were 10 papers published on network congestion. And in last year, in 2021, there were 990 papers published on the topic. So obviously network congestion, every major lab have published multiple papers on this topic about what it is and how they're trying to deal with it. And so you could say there's a congestion of network congestion papers now, but it's obviously becoming a hot topic. And you can see why. So this is a quote from just one of the papers. This is a NERSC paper that was given at the Cluster Computing conference last year, and it shows that a given application can suffer terribly in terms of its ability to complete on time under network congestion, and it takes anywhere from a 40% hit to a 700% hit. And so what we've done here at GigIO is we have finally come through with what we think is we've been told many times is the holy grail, that we can route PCI. And so we give you not only the ability to do this server composition, which is incredibly useful, but you can also go across your entire traffic class. So anywhere, all of the extended composition, the computational, even the file and object store traffic can all run beautifully across fabrics, and we'll talk about that shortly. And so it's really about giving a tool to the folks that run these networks. And what we find is that in an awful lot of cases now, people want to combine it. And when they start to work with fabrics and they start to understand the differences here, they would say, look, my file and object store tends, and I'm staying away from definitives, tends to be bandwidth driven. And I have my storage system that's set up, it's running across a high bandwidth Ethernet connection. I want to keep it that way. Okay, great, keep it that way. There's, just because you have the tool that'll work across the entire thing doesn't mean you need to. And so a really common approach is they want to take the computational traffic, they want to take the extended composition traffic and the server composition traffic, which tends to be latency driven, put it on a super low latency network and take advantage of both networks. And oh, by the way, everything runs faster on the Ethernet network that you now took all this traffic off of. So at the heart of what we do is this, like I say, we figured out how to route PCI Express. So server 1 to server N is all talking across fabrics. We never do any network translation. We never do any conversion on either end. And so the latency numbers are well under a microsecond, right? So it's in the hundreds of nanoseconds. And so now you can, you can take and disaggregate things and it all comes back together beautifully, right? Or you can decide to combine networks, as I suggested before, take the really latency sensitive traffic and put it onto fabrics, put the bandwidth traffic onto Ethernet, and use both of them together seamlessly. Now, I'm going to go through a quick slide to show you how we scale up and scale out. So scale potential is quite large, as you will see. At the heart of our system is a top of rack switch. It fits into, we have various software that can run on top of this. We fit into just about any topology domain that you might think of, leaf and spine being the most common. And so we can create topologies of arbitrary size doing this. We have plenty of customers that do this. They plug in application servers. We have an interface card that allows you to connect directly into the Fabrics network, which today is based upon PCI Express as a data plane. And they'll take advantage, you know, if they're running MPI workloads or if they're doing intermessage server traffic, they take advantage of the really low latency, and this is great for them. Now, others will come in and add just a bunch of flash, and we can attach portions of this storage onto individual applications. This is very similar to what Sumit had talked about in terms of being able to take resources and bind them to certain servers and move them around as you wish. Now, with our server-to-server capability and the fact that we have written a number of transports, in this case, the NVMe OF transport, you can connect into storage servers or into storage systems, and you can run NVMe OF traffic. And this RDMA traffic, this NVMe OF traffic across fabrics is exceptionally fast, and we're happy to share data. And so things like Intel Optane now become networkable, and you can share them at ease. Of course, all the other SSDs do the same thing. And what we do with storage, we can do with GPUs. So you can either attach a box of GPUs and share them between multiple servers at will, or you can also attach to a GPU server or multiple GPU servers and run jobs from the other application servers on the GPUs that are sitting in GPU servers, or create nickel rings or Rickle rings of artificial size. And so if you need 8 or 16 or 32 GPUs for a job, that could be a handful of servers in order to do that. Now, in reality, that box will handle, it's really just a bunch of anything. And it can be FPGAs, and it can be custom ASICs, and it could be different kinds of GPUs. It can be a mix and match. It doesn't really matter. It's that particular box is a standard PCI slot, and it's got plenty of power in the box. And if it plugs into a standard PCI slot, it's just going to work. And at the heart of what we do, PCI Express now is a memory-centric network. And so the concept of shared memory, right? You know, Debinger talked about this yesterday in the CXL pitch. You know, people want to get to a shared memory or a memory pooling concept. We can actually do it today, and customers of ours are taking advantage of that. The limitation today is it is in fact going across the PCIe, and CXL will enable us to do this much, much faster. So, you know, we've been a very early member of CXL. We contribute quite a bit in the community there, and we are actively engaged with CXL. And it's obviously going to be an easy fit for us in our data plane. So we believe we deliver some really significant value. One side is the composable infrastructure, the disaggregation capability, the compose on the fly, creating virtual machines. It works, and it works beautifully, and you can move resources at will. And now you can also separate out your traffic. You can move latency sensitive traffic to a latency, really a very low latency network. And you can combine different kinds of networks and you can decongest your existing networks. From the very beginning, we were designed with open in mind, and everything about what we have done has been towards open standards and open concept. We start at Fabrics, there's 3 layers to it. There's the data plane, which today is running on PCI Express Gen 3 and Gen 4. CXL is coming very quickly now, and it will be part of our data plane. Running on top of the data plane is our Fabrics Fabric Manager, our control plane. It sets up everything about how we operate the network and runs that. It collects all the telemetry information from any resource that's plugged in, so you can continually monitor health and so on across the network. And then we have a group of host services. So we literally work with any server. We plug a card in, whether it's AMD, Intel, or ARM, whether it's Dell, HP, Lenovo, Supermicro, doesn't matter, right? We run across all the server platforms. And as I said earlier, anything that fits into a slot generally works, right? We've tested all sorts of devices from the folks listed here and many others. And I don't think we've ever put a device in that simply hasn't worked if it conforms to the PCI standard. The host services for us that we have written, and so we plug into a ton of existing frameworks in the marketplace. We've written the NVMe OF transport. We've written a GPU direct RDMA transport. We've written a libfabric transport. You can even run TCP/IP at higher speeds across this network. We've written that transport. We work with all of the management software that's out there. We're doing deep integrations together with the folks that you see on the page. Bright Computing, Supermicro, Define Tech, Control IQ, Cloud Shell, any of these environments, they pick up and use it. Whether you're using Slurm or Grid Engine or PBS Pro, it is a way of being able to easily control the network. For the folks that love to do their own scripts, and if you're writing your own automation software, generally they like to come in through our REST API as opposed to the Redfish. And we work with all the automation tools. And this all sits under the AI and data science frameworks and under the container management and Jupyter notebooks and VMs. We simply plug in and work. It's all based on standard, right? We work to the PCI SIG, CXL, etc. And so really the benefits here is it's about future-proofing your, the data centers, easily being able to fit into upgrade cycles. The performance is super, and with moving traffic classes, your existing networks even run faster themselves. And finally, the management capability is really quite good, and the scale capability, because we operate through extended composition and so on, is also really quite good. So that was a really quick overview. We'd love to go into detail if people are interested. You got a variety of ways here to contact us. We can take you through a demo, and we're happy to answer any and all questions.
Thank you, Alan, for your presentation. I think we're pretty tight on time, so we have to move on to the next speaker now. Thank you.
Okay, thank you very much.